Okay, here's a question where you're going to have an initial concentration of one of the products in an equilibrium reaction that's not equal to zero. In the previous chapter, when you're talking about weak acids and weak bases, you certainly had the opportunity to have one of those situations, but usually you could deal with it with another method like the Henderson-Hasselbalch equation. But in this case, you're not going to get around it. And this is one of the examples of that problem, of that kind of problem. It starts off with the idea that says, look, we're going to have a solution, and that solution already has some sodium fluoride in it. And sodium fluoride is completely soluble. So if I start out with 0.25 molar sodium fluoride, then I have 0.25 molar sodium, and I have 0.25 molar fluoride as well. Now, what about the actual equilibrium that's going on with calcium fluoride? Now, calcium fluoride is not soluble. It makes an equilibrium, and it has its own equilibrium product. Its products are calcium ion and fluoride ion. But here's that part that I was telling you about. The initial concentration of the solid is obviously ignored. The calcium ion concentration is zero, but we already have some fluoride in the solution, 0.25 molar. And so we need to take that into account in our ice table. But we do everything else exactly the same way. What's the change? The change is plus x here, plus 2x there. So that means at equilibrium, I have x, and I have 0.25 plus x. So let's write down the equilibrium expression now. I get the equilibrium constant, the KSP, 1.46 times 10 to the 10th, 10 to the negative 10th. That equals x times 0.25 plus 2x, and that entire quantity squared. Okay, well, what are we going to deal with? If we distribute, if we square what's in the parentheses, and then multiply everything by x, we'll end up with a polynomial of the order 3. So we'll get some x cubes in there. So what we need to do is we need a way to simplify this. And so before, what we would do is we would neglect x. But we can't just get rid of x and leave the 2 there where it says 2x. So the question becomes really, what about 2x? Is 2x small enough? In other words, if I have 2x and I add it to 0.25, if x is so small that when I double it and then add the result to 0.25, I essentially still get 0.25, then it's negligible. And so let's assume it is for the moment, and let's see what happens. So 0.25 plus 2x is essentially 0.25, so I still square it then. And so what I end up with is that x equals 2.34 times 10 to the negative 9th. So was it small enough? Yeah, absolutely. Even 2x is negligible when compared to 0.25. Now, the question asked us to figure out the concentration of calcium ions. And of course, X is the concentration of calcium ions. So I actually know the answer. It's 2.34 times 10 to the negative 9th molar. That is the final answer for the problem. Okay.